Hi, this is a do-it-yourself video tutorial on printed circuit board manufacturing using toner transfer and cupric chloride etchant techniques. You can find more of the information in the article below. However, this video will go in-depth to most of the procedures. You can find most of the materials commonly available either in your home or at a hardware store, and the chemicals you will need will be either available at a hardware store or you can go online and find an alternative ferric chloride etchant solution. However, this article and video tutorial will go further in depth about the cupric chloride etchant solution only. The first thing I'm going to talk about is safety. One of the most important things to consider when handling chemicals is personal safety. I strongly recommend that anyone watching this video and that plans to etch their own circuit boards acquire as many of these safety items as possible. Some of the things you will want to consider are a lab coat, such as I'm wearing. You may want to consider a all-cotton lab coat if you're going to be using it for other things. Polyester is extremely flammable and is known as a bit of a death trap. This is a polyester one because I'm not using any flames to heat anything. However, if you use a Bunsen burner, strongly recommend that you get a cotton lab coat. Another thing you want are goggles. These are your standard lab goggles. However, for beginners, I also recommend a indirectly vented, completely enclosed type goggle, which helps protect your eyes from any chemical splashes. Also, you will need some disposable gloves, and during some sanding, at least a N95 NIOSH rated mask. They can be disposable or other types. However, they need to prevent you from inhaling copper particles. Another factor to consider when handling chemicals and etching your own circuit boards is a large source of water that is readily available, such as a laundry tub. You want a very large open space to handle any tubs of etchant that you may need to dilute or be able to wash your hands or your eyes in an emergency. I strongly recommend that you have enough space underneath the faucet and around the tub to get your entire eye or head underneath the faucet. And in the event of a chemical splashing your eye, wash your eyes for at least 20 minutes. So on to the good stuff. First I'm going to talk about the cupric chloride etchant itself. For this you will need a cupric chloride etchant of copper, such as copper wire scrap that you can dissolve in hydrochloric acid. I already have a prepared bottle. It's a very deep green. Also you will need hydrogen peroxide, preferably of a strong concentration such as 30% at least. Any lower concentrations will only dilute your etchant and give you headaches further down the road. Another safety item is to have a box of baking soda to neutralize any acid spills during the etching process or during the handling of the etchant. First we're going to prepare our etchant. The first thing you want to do is get a beaker and pour your etchant into the beaker. Put it on a heat source and warm it up. Be very careful when pouring your etchant out of a bottle or acid. You can use a glass stir rod like this to help control the flow and prevent splashing. Keep in mind that this will also cause corrosion of any nearby metal objects, such as steel, copper, or even the heating element on my hot plate. You want to heat your etchant, not to boiling, however you want it to be warm to the touch. This is just so you can accelerate the etching process. You'll note that this is just a standard kitchen hot plate, repurposed for this use. You'll want to use Pyrex glassware, and always wear gloves during the process. You'll also want handy a tray to hold the etchant and your circuit board during the process, and plastic tweezers to agitate the board. If you are a little more ambitious, you can use a vertical etch tank with a heater and a air stone to help agitate the etch solution as well. For toner transfer, you will need a laser printer printout of your PCB artwork, some copper clad, a cutting surface and a knife, a old iron. Please don't use your parents' or a good iron that you use for clothes. Once you start using this for printed circuit board etching, you will destroy the Teflon coating found on most irons. Also, you will need plenty of paper towel and a solid heat-resistant surface, such as this desk. The first thing you want to do is to cut out your PCB artwork from the original printout. Carefully cut around the artwork. Take your time and score at least once or twice. You don't need to go through the entire paper in one single cut. Accuracy is more important than speed. Also be very careful when cutting out using a knife, as they're sharp. Another tip I recommend is while you are handling any of the materials, use disposable gloves to prevent fingerprints from getting transferred to either the paper or the copper clad. Another key step is surface preparation. Once you have your artwork cut out, avoid handling the toner side. Use your fingers only on the edges just to keep fingerprints or dirt from getting on there. You can use a small compressed air source just to clean it off. Set the artwork aside for now. Take your copper clad, your artwork, and just a regular Sharpie marker with a ruler, and trace out the dimensions of your board with a little room to spare on the sides. If you're doing double-sided boards, you will want to cut your circuit board a little larger, toner transfer to one side, and very carefully drill registration holes which help you line up the second side of the board. Also make sure that you mirror and flip the appropriate side of the circuit board, otherwise your artwork will not line up. Once you've traced out the dimensions, double check your size. Once you know that you have enough space on your circuit board, you can set the artwork aside for good and begin cutting and preparing the circuit board. Make sure you have a good cutting surface and a strong knife. You can use a ruler to help as a guide when you're cutting. The key to cutting circuit board material is to score both sides as deep as you can without injuring yourself. And then once you've scored through both sides, you can place the circuit board against the edge of a table and snap it. For very short cuts, you can also use tin snips. However, I don't recommend them, I don't like them. They tend to cause the fiberglass material to fray and chip, and it doesn't look really good in the end. So once you've cut one side, transfer your markings to the other. I just use a little rocking motion, but you can take your time and trace it out. Another tip is to start gentle and transfer your cut into the fiberglass before actually starting to cut deeply into it. If you try and press too hard on your first few passes, you'll end up having your knife slip and create a bit of a trough in the wrong direction, which will make your knife tend to go in that direction instead of the straight line. Once you've properly scored through on both sides, make sure that you go through the entire copper surface, place it on the edge of a table, and press down gently until you hear the snap. You may need to follow up with a bit of knife action to clean up the edge, however, in this case it seems to have gone pretty cleanly.